All right. Hey, fourth graders. Before we begin this lesson today, I want to remind us all about the use of a protractor. And I thought I'd use this applet to show you and demonstrate that. First of all, you have a standard or basic protractor, just like the one that you either borrowed from us or at home. It's clear so you can see the angle made by two line segments. So we want to get familiar with how do we set up a protractor to measure the degrees of an arc. We have two line segments, BA and BC, if you're looking at this uh, really closely now. And we're going to find the anchor point of our protractor, which we see is right there in the center at the bottom of the semicircle. So what we'll do is now bring that protractor, just like you would at home, and locate where is the vertex that's formed by these two line segments. And it happens to be right there on B. So we'll place the anchor point right over it. And as you see, you could even put your pencil or see right through that small hole to get it lined up. Now we have to look for where's the zero start on this protractor. Well, in this case, this is a one directional protractor. So the zero, you'll notice, is right there on the right side. So we're going to bring that zero up to the first horizontal line and line those up so that we call it alignment is exact. Then we're going to measure and go counterclockwise. That means along the arc or the rainbow, if you want to say it that shape. And we're going to go left. And if you count, you'll say each single line or hatch mark is going to be 1 degree. So as we count up, we're going to 10. I can see 5, 10. And then it starts to slow down as we get closer to that point A, and that's the BA line segment. And it's somewhere between 11 and 13 if you're looking closely. And indeed it is. It's 12 degrees. So that's where we would take the measurement and call it out. Angle ABC equals to 12 degrees. So what I'd like you to do is just get familiar with the use of it, play with your protractor in this lesson. I'd like to have one more video that I've taken an excerpt from that I'd like you to see a different type of set of protractors that you can get used to. One's a 180, like the one you have, or there's another one called a 360.
Here is I've got an angle. It's kind of right here, sitting right here. And then I've got a couple of different protractors. I've got the circular protractor here, and then this is a traditional protractor here. And even with the traditional protractors, there's a bunch of different kinds of protractors, but they're all basically used the exact same way. And I'm going to put this traditional one aside for a second, and I'm going to grab this circular protractor. And what's really cool about my circular protractor is I can make it big and I can make it small. Okay? Now, if it's too small, we can't read it. But here's the neat thing, is unlike a ruler, like if you stretch out a ruler, all of a sudden you're no longer measuring inches, or if you shrink down a ruler, you're no longer measuring inches. The neat thing about a protractor is no matter how big or small your protractor is, you're still going to measure the correct angle. So here's the idea. You take this protractor and you'll notice that this protractor has a centerpiece and a point. I call that the target. And then it's got a 0 degrees somewhere. Even the traditional protractor, and I'm going to get this, the traditional protractor has a target. Here it is, here's the target, and here's the 0. So that's going to be common on every protractor. You're going to always have a target, and you're always going to have a 0 somewhere. All right, so let me get the circular protractor. And the idea is you put the target right here on the vertex of the angle, on the corner of the angle. And then you rotate your protractor so that 0 lines up with one of the legs of the angle. Boom. Pretty close, right there. So now I can zoom in and I can see there that my angle starts here at 0 and it goes 10, 20, 30, 40, 50, 60, 70. That looks about to be exactly 75 degrees. So I can measure that and that says, all right, it's 75 degrees. Now the cool thing is If I shrunk my angle down, all right, so we now know that the answer is 75 degrees, but if I shrunk my angle down, my protractor I mean, and I measure that right there, now you can see that the angle, and I'm going to have to zoom in, even though I shrunk my protractor, I still get the exact same measurement of my angle reading. So I'm going to start here at 0, 10, 20, 30, 40, 50, 60, 75. So both times, whether I used the big protractor or the small protractor, in both cases, I got 75 degrees. And that's kind of the neat thing to me about the protractors is that the protractors, it doesn't matter whether some people are using a big protractor and other people are using a small protractor. No matter what, whether you're using a big protractor or a small protractor, you're always going to get the exact same measurement, assuming you do two things. One, you put that target directly on the vertex, the corner, and you line up your protractor so that the 0, which right now is right here, so that the 0 lines up on one of the legs of the angle.
All right, today we're going to have some fun looking at some angles and using our protractor to determine the angles. So our goal today and objective is using protractors to distinguish angle measurements from their lengths. Okay, so here I've chosen A and B and C, from our page here. So what we want to do first of all is, because the page is small and our protractors are large, it may be difficult to figure out what the line segment is pointing to on the degrees or angles that we're measuring. So one way to go about it, if you have an iPad or you're able to extend it, is we'll zoom in here, and in this case I'm going to take my highlighting tool. I'm going to place it over a few of these line segments to extend them, and let's use a different darker color. Let's try that. So I'm going to start at the vertex point right here. Then I'm going to extend it out much further so that I can get a better read using my protractor. So I'll place it there, and I'm just going to extend that one out. Then I'm going to do the same for the other line segment. You can hear my protractor clanking, so though you can't see me actually doing it, you can see generally my idea what I'm doing. Now we have the two line segments that have been extended, and now we can place our protractor down on the page. Okay, so my first goal is to find the target or the vertex. So there's the vertex right there, that point. I'm going to locate on my protractor the target or the crosshair, and I'm going to place that hole on the bottom. Next, I have a couple of choices. I can first figure out which line segment do I want to use as my starting point. And in this case, it's probably going to be easier with the page just being this straight up and down to use the line segment that we see horizontally. So this line segment is what I'm going to be using as my 0. So I'm going to go ahead and, with my protractor, line up the target again, and then that's going to be at my 0 point, so that's going to be 0 degrees. On your protractor, you'll just see a line that's horizontal. Then I'm going to remember I'm going to be measuring. I need to start here at this angle 0, and then I'm going to be measuring all the way till I get to the other line segment. So I'm going to follow up. So this is 10, 20, 30, 40, 50, 60, and then when I hit my point, approximately right there. So if we wanted to be 100%, we can extend that line out. Okay, and likewise, we can extend this line out on the bottom. Okay, and if we look on our protractor, we could see that the angle, and we're going approximate because we don't have like a laser guide to figure it specifically, but we're looking at between 60 and 70, right in the center. So I'm going to eyeball that and say it's 65 degrees, okay? And what they call this part right here, that's near the vertex, this is called an arc, right? Because an arc is basically like part of a semicircle or a segment of a circle in this case. So here, this arc degree is 65 degrees. If we want to be specific, we could label these points. We could label that, this one over here, we can label it A, B, and C. And then we can make a statement if we wanted to go that far and say angle ABC is equal to 65 degrees. Okay, now let's take a look at this one. Again, just take your time, follow the steps that you need to get a accurate read. Okay, so we're going to again extend from the vertex these line segments. So here I go, I'm going to extend this one out. I'm going to extend the other line segment. Okay, now I can go ahead and turn the paper or your page so that you have a starting point. So I'm going to turn mine clockwise. So now what I'm looking at with the target point right here is where I place the center of my protractor. Then I'm going to go ahead and take that measurement starting from the 0, which we know is here, 0 degrees, and I'm going to start moving 10, 20, 30, and approximately we're looking at just shy of 35 degrees. So right there. And so that would be 34 degrees. Okay, so I think you got the idea here. I'd like you to take the time to practice the varied sets of angles, and then I'll go back and give you some of the answers for what these degree measurements are. Okay, so there you have those ones. We can practice another. What happens when the line segments seem to be facing downward? Well, one, you could just turn your paper upside down, and then you can measure from there. It's your choice to think outside of the box. You don't have to hold your paper just in the standard form. You could turn your page upside down and then extend those. So I'm going to actually turn my paper upside down for E. And then I'm going to extend my extend the line segments. So I'm lining it up, and then I'm going to go ahead and make sure it's following a straight line. That's going to be really important from the vertex outward. And then the same goes for this one on the other side. Extend that arm out. Okay. And then I'm going to now take my protractor, and this time, instead of using the right side of the protractor where it starts at 0, I'm going to use the left side. So I find my vertex. There's the vertex point. Place the target on top of it. And then line that up to where it says 0. Okay. So that's 0 right there on the horizontal line. So that's going to be my 0 degrees right there. Then I'm going to, again, do the same thing, but this time move clockwise. So you're going to see me do that in a second. I'm going to zoom in a little bit closer here so you can see it happen more clearly. Okay. This takes a little doing and just precision, but point is we want to go ahead and start measuring. So I got 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and 105. So that's going to be, I'm going to go ahead and turn my page over again so you can see me writing up, right side up, 105 degrees. And this time you notice I measured from where? I measured from this line segment in this direction. And that was because I turned my paper upside down and measured clockwise. So I got 105 degrees approximately for this angle. Okay, let's look at I. Okay, so this one is, notice the angle, the vertex is on the right side, and I want to go ahead and extend those arms out again. You have a lot of options in how you want to use your protractor. Okay. Go ahead and extend them out. Okay. And then I will take my protractor and place the target on the vertex again here. Okay. And once I line that up correctly, then I can go ahead and measure. I'm going to go clockwise again, starting at my 0 point down here, and go 10, 20, 30, 40, and right there. It seems to be, it made it right there between 40 and 50, so that's going to be 45 degrees. And the interesting thing about that, I want to make note of, is that, well, what is 45 degrees? 45 degrees is, if I take my protractor and I place it on the vertex again, and I go ahead and create a 90 degree right there, these two angles here and here should be the same. So if this one is 45 degrees, because we know that this makes up a 90 degree, well then this also should be half of 90 is 45. So 45 plus 45 is equal to 90 degrees. Okay, so just some ways to play with angles and look at their geometries to help you along. Okay, number 2, using the green and red circle cutouts from today's lessons. Well, we didn't have that in class, but you can take a template or a piece of paper at home, get a big coffee mug, and trace out a large circle for the red one, and then get a small cup and trace out one for the green one. Then fold them in quarters like you see in the picture here, right in this picture here. If you fold them in quarters, then you essentially have this A and B shape here, and they're different sizes. So it says, using these two cutouts, explain to someone at home how the cutouts can be used to show that the angle measures are the same, even though the circles are different sizes. So I didn't specify what size, or you wouldn't call it the diameter of the coffee mug is, nor did I say how large the cup that you use to trace the smaller circle, because it doesn't really matter. Our main thing understanding with this angle measurement is no matter what the size of the circle, their angles are going to be the same, because the angles don't change when you change up the ratio or the size. Okay, so how would you explain that? Write words to explain what you told your parents. So I'm interested to hear what you guys come up with, and the way that you might explain how do angles stay the same even though the circle sizes that you're using are different. Okay. 3, use a protractor to measure each angle. Extend the length of the segments as needed. So we learned how to do that before, extending them. So if we want, again, we can extend them. Okay, so I extended them. When you extend the line segments, does the angle measure stay the same? So what do you guys think? Does this angle right here, this arc, stay the same when you extend the line segments? Same thing goes for B. So it's essentially the same question. Do you think that these angles will change if you extend the line segments. And I'm extending them. Do they change? Question mark or not? And the answer would be no. The angles always are going to stay the same no matter how long you extend these line segments on A and B. Explain how you know. Well, you can take your protractor and measure it. So you can use protractor measure, and it's going to be the same obtuse angles for both of them. This one, I'm going to guarantee you, it's 180 degrees. And then this one over here, you're looking at approximately 172 degrees. Okay, so the answer again is no. Angles, comma, stay the same. Exclamation, because nothing changes. Again, that's the true fact. Okay, so all right, here are the answers for these problems from lesson 6. Feel free to pause your YouTube video as needed.